Flap, 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 thud. Ouch! Why is it so very hard to fly with just homemade cardboard wings? Our human bodies just can't flap and lift off the ground. But stick around, because in 2 minutes, I'll show you the amazing machines we built to soar through the sky. To understand why we can't fly, look at this diagram comparing our bones to bird bones. Ours are thick and heavy, but a bird's bones are hollow and light. Plus, birds have huge chest muscles perfectly built for flapping. Ours are way too small. Because our bones are heavy and muscles small, no amount of flapping will work. To get off the ground, we have to build machines. Let's step into a wind tunnel. This is a special room where we can watch exactly how air moves around different shapes. Here, scientists study an invisible upward push called lift. Lift is the force that pushes a heavy flying machine up into the sky. This drawing shows how a curved airplane wing works. When air rushes over and under that special curved shape, it actually pushes the wing right up. Look at this overgraph of an albatross bird flying over the ocean. The upward push of lift is so strong, this bird can ride the wind for hours without flapping its wings even once. By copying that curved wing shape, humans found a way to get an upward push without needing giant flapping muscles. But lift alone isn't enough. To fly, you also need a forward push called thrust. Thrust keeps a shape moving fast through the air. We can make a tiny bit of thrust by running on our own feet. But look at this picture of an airplane's big spinning propeller. That heavy machine needs a powerful engine to pull it forward. Animals make thrust with their bodies. See the blurred wings in this picture of a hummingbird? It flaps up to 80 times every single second. A human could never move that fast. Speaking of moving fast, why did the airplane get sent to its room? Because it kept making so many plane noises. Vroom. But seriously, to beat gravity and fly, those two forces, the upward push of lift and the forward push of thrust, must always work perfectly together. This animation shows how airplanes combine both forces. When the engine pushes forward to make thrust, the curved wings slice through the air so lift pushes up. Look at this helicopter resting on the grass. Those long spinning blades on top are actually skinny wings. The engine spins them around and around to make lift straight up into the air. Take a look at this historical photograph of the very first airplane flight by the Wright brothers in 1903. Their machine had lift and thrust, but it only stayed in the air for 12 seconds. 12 seconds was just the start. Today, huge airplanes carry hundreds of people and fly over the clouds for many hours without stopping. We couldn't change our heavy bones or small muscles. Instead, we used science to build incredible machines that fly for us. Let's see what you remember. Shout it out. What is the upward push from a wing called? It is lift. Question 2. Can a human flap their arms hard enough to fly? The answer is nope. Our heavy bones keep us on the ground. But knowing how to put a curved wing and a strong engine together lets us explore the sky. This picture shows a fun experiment you can try with a grown-up. Hold a small strip of paper right under your bottom lip and blow straight across the top. Watch the paper lift right up. Science helps us solve big problems and do the impossible. Subscribe to Open Learning Lab so you never miss our next adventure.